Righto, we don't need that calculator. Our last examples for this section. Evaluate. 1 plus 2 plus 4 plus 5 plus 7 plus 8 plus 10. Now, hang on. The reason I'm going, hang on. Well, it's not an arithmetic because we're not adding the same amount each time. It's not a geometric because we're not multiplying. Times 2, cool. Times 2. No, wait. So it's not a straight up arithmetic or geometric. But wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ah. Can you see what's going on? Looks like we're missing all the 3s. Look. There's a 3. 6 should have been there. 9, 10, 11, 12. 95, 96 is a multiple of 3. 99. Okay, so actually, it's like we've got this sequence that's like 1 plus 2 plus 3 plus 4 plus all the way up to 100. And we just need to subtract 3 plus 6 plus 9 plus, and so it goes up to 99. Okay, that's quite neat. Okay, well, we've got an arithmetic progression here, an arithmetic progression here. Do you know how to work out the sum of this arithmetic progression and that one? And therefore how to subtract them and how to change that 6 to a 9. And you're good to go. Okay, well, let's see. This here, well, we know that we can see that a equals 1. Our constant difference is 1. Our n is, we don't have to substitute into a formula. We can read off that there are 100 of them. So for here we know that Sn equals, what does Sn equal again? Well, kind of pausing to think also, which version are you going to use? I mean, we could have n over 2 a plus l. That seems quite easy. We know n, we know a, we know l is 100. So this part's going to be easy, right? 100 is n over 2 a plus l. So that's that part. Now let's work with this other part here. A is 3. Constant difference is 3. We know L is 99. So we're going to probably use the same formula because it's a nice, neat version of the formula here. And let's move right out the way and say, well, n over 2 a plus L. Now, how many are there? 3, 6, 9. How many are there? I don't actually need to think of this in terms of Tn. Kind of makes sense that they're 33, right? Because 33 times 3 gives us 99. If you wanted to think of it in a formula, Tn equals 3n. So 99 equals 3n. But I think we could get there. So last term's 99, n is 33. Punch that into a calculator, punch that. So our final one, let me just show it. Our sum is, let's do it nicely here. 100 over 2, 1 plus 100, and we need to subtract all those multiples of 3. Plug that into our calculator, get some sort of answer. I'll be back with the answer once you've put it in. And what do we get? 3367. I hope that you got something similar to that. Well, actually exactly the same. Okay, let's do our last example. And that is, we've got 1 plus 2 plus 4 plus, so what's happening here? So it's not multiplying by 2, not so much. Okay, so just going to kind of talk through it so we can maybe see how we can make sense of it. 1, 2, 4, 8, 16, 2, okay. 5, 10. So let's just see if we can. So here's what we're trying to do. I think we know what we're trying to do. We're trying to break this up into 2 different series. So I'm looking at to see, can we find hidden in there an arithmetic progression and perhaps also a geometric progression? Can you? And what's the arithmetic progression and what's the geometric progression? Okay, well, I'm going to circle the way I see it. I mean, like all of these, there are different ways of doing it, but 1, 2, 4, 8, 16, 2, 5, 6. That looks like a lovely GP. 1, 2, 4, 8, 16 plus 2, 5, 6. And our arithmetic progression, let's see, is it the ones left? 5, 10, 15. So it looks like we're going 5, 10, 15 plus up to 260. I should rightly have had a plus there. Okay, so we've got a GP, an AP. I think you know how to work out the sum of each of these. Do you? Well, hopefully you know A, you know R, you can work out the number of terms. You know A, you know D, you can work out the number of terms, sub it into a formula, get your answer, go for it, and then I'm going to do last year's test. So for last year's test, where am I jumping around to? Last year's test, I want you to do the whole thing and hand it in by the end of Thursday. Now, the sooner you hand it in, the better, because I really want to see your working, give you some good quality feedback on your work so that you can look to that and learn from it. So, yeah, give that a go, enjoy, and, yeah, I was going to say, as always, enjoy, but always enjoy. Okay, goodbye.